for the introduction, Alicia. So my name's Anthony, and I'm here to present my research over the summer, decoupling environmental impacts of food from economic growth. So I spent the summer researching whether countries have been able to decouple the environmental impacts of food systems from economic growth. Historically, economic growth has led to increases in resource use and environmental impacts, and decoupling refers to an economy that is able to grow without those corresponding increases in environmental pressure. For this research, I focus on two forms of decoupling: resource decoupling and impact decoupling. Resource decoupling refers to an economy that is able to grow while resource use grows at a slower rate, and impact decoupling refers to an economy that is able to grow while environmental impacts decrease. And for this research, I focused on three aspects of agriculture: land use, fertilizer use, and greenhouse gas emissions. In terms of land use, we use half of all habitable land on Earth for agriculture. And when it comes to fertilizer use, 50% of all nitrogen is lost to the environment as runoff, which pollutes our natural resources. And agriculture emits 30% of global greenhouse gases. So in terms of decoupling, what do we want to see in terms of these three aspects of agriculture? Well, for land use, we want to see a reduction in the amount of land used for agriculture. In fertilizer, we want to see a reduction in the amount of fertilizer used for food production. And lastly, we want to see less greenhouse gases emitted from agriculture production. So how I went about getting these results is I took data from the Food and Agriculture Organization of the UN and Our World in Data. I then processed the data, combining them by countries and income level, and then displayed those countries by income level and to show trends. So now to the fun part, or the actual research, is here we have a graph of agricultural land use that includes cropland plus pasture land. And I graphed hectares per capita over GDP per capita for all four income groups. And we can see here that as GDP grows, income groups use less hectares per person for agriculture, and specifically high-income countries use less hectares per person than the other income groups. And if we take a closer look at a closer look at representative countries for these income groups, we can see that the U.S., Mexico, and India have all decreased their land use per capita as their GDP has grown. The only exception to that rule is Niger, which is a low-income country. And interestingly enough, I think I have an answer for that, and I didn't have an answer before. And it's they just had a coup d'etat yesterday. So political instability might be the reason that low-income countries can't decrease their land use and increase their GDP. So why do we see these trends? Well, increases in GDP per capita coincide with the sequence of land use transitions. So as countries grow their GDP, they go from natural ecosystems to frontier clearings to small-scale subsistence farming, and then eventually intensive agriculture. And that's where we notice a tipping point, where countries have been able to, because of innovation, countries are able to produce more food on less land, and additionally, as the population gets richer, they become more environmentally conscious, and farmland is returned back to natural ecosystems. If we move on to fertilizer use, I have here a graph that shows kilograms of nitrogen per person over GDP per capita for all four income groups. And we can see here that as GDP grows, nitrogen per person also increases. And specifically, high-income countries use more nitrogen for agriculture than the other lower income groups. But there is a trend upwards for all four income groups. If we look at, we take a closer look at actual countries, we can see that the US and India, the two largest producers of wheat, have increased their wheat yields while also increasing their nitrogen per hectare. And the only exception to that rule is countries like Denmark, who have been able to decrease their nitrogen use while still increasing their wheat yields. per hectare. And so why do we see these trends? Well, increases in nitrogen use are related to the desire to produce higher yields, and that holds true for higher income countries. Denmark, the exception to that rule, has been able to decrease its fertilizer use because of government policies that they have been implementing since 1985, which have targeted pollution from nutrient loss. And finally, if we move on to CO2 emissions, here I have a graph of CO2 emissions from cereal production over wheat yield, or for wheat yield, sorry. And here the graph actually shows tons of CO2 per person over GDP per capita for all four income groups. And the same trend we see in fertilizer use, we see in CO2, which is that high income countries use more CO2 than lower income groups. And if we take a closer look at actual countries, we can see that the US and India have increased their CO2 emissions while increasing their wheat yields. Denmark, curiously, has also increased their CO2 emissions while increasing their wheat yields, but they've done that at a much slower rate. Since 1961, they have been able to only increase their CO2 emissions from around 5 tons to around 10 tons of CO2 in 2021, which is far below India and the US. So why do we see this trend? Well, there's a correlation between economic development and greenhouse gas emissions from cereal, which is tied to intensive farming. Intensive farming requires the use of mechanization, and mechanization burns a lot more fossil fuels. So that's why higher income countries emit more CO2. So in conclusion, what does this mean? Back to my research question of whether countries have been able to decouple environmental impacts of food from economic growth. Well, we see, let me slow down. Well, we see some resource decoupling in land use. As GDP per capita increases, hectares per capita decrease. But the same cannot be said for fertilizer use or CO2 emissions. As GDP per capita increases, those two factors also increase. The exception to that rule being countries like Denmark, who have been able to decrease their fertilizer use while increasing their wheat yields. And I would like to thank Matthew Burgess, Ashley Dancer, and Margaret Hegwood for their mentorship and aid and support throughout my research process. I would also like to thank the Center for Social and Environmental Futures Lab, who generously lent their time to help me learn how to code and advice on my research. And finally, I would like to thank Alicia and Dana and the RECCS program for allowing me to partake in this internship.
Questions?
Yes.
How do we be more like Denmark?
How do we be more like Denmark? Same thing as Wookie said. We have to pressure our government to pass more legislation against pollution.
Sorry. So does importing grains from elsewhere, does that impact anything?
No, great question. So actually, research has found quite the opposite. As countries increase their cropland, they increase their imports. What? And the opposite is found as countries decrease their cropland, they decrease their imports. Yeah. Yes. Why? Why? I don't know. That's future research. Someone knows. Not me.
Any other questions for Anthony?
Oh, yes. Yes.
So, really great talk, Anthony. So you showed that as countries get richer, they use less land and they use more fertilizer and more CO2 for mechanization. Can you think of how those trends might be related to each other?
The way I could see it is that when you use less land because you turn the agricultural land you do keep is intensive agriculture, which intensive agriculture needs to have more fertilizer use and as a result uses more mechanization, which produces more CO2 emissions.
Perfect.
Ooh. Yeah.